In the box modeling part 2 video, I talked about how to use control loops around all corners. In that, the control loops went all the way around the model. It is entirely normal and suitable for a control loop to go all the way around the model until it isn't. For instance, on a complex hard surface model with a lot of details on one side, the control loops holding those details together will sometimes create a high concentration of lines on the other side of the model. That is especially unwanted on asymmetrical shapes. There are going to be times when you want to keep the control lines on one side and reduce the number of lines on the other side, and that's done by conjoining the lines. Let's look at how complex geometry can gradually reduce from one part of the model to the next. Let's say I wanted to add some detail to the bottom of this shape. I would first have to remove some of these lines, but before I do, I need to think about what amount of detail I need. First, determine if the detail needed can be achieved by making a separate shape on the surface of the model. Second, before editing any lines, use blocking to visualize the additional detail. Third, if the detail needs to infuse with the shape, plan how to shift and reduce the lines, making way for the additional feature. In this example, I infused the additional detail at the bottom of the original object and then reduced the extra lines into one at the intersection where detail is needed. That clears the way for the new shape and either uses existing lines or redirects lines into corners. Usually, this is detail that would be separate from the model, but it all depends on how it should look. Okay, so what if I wanted to make a series of depressions into this underside? One strategy is normalizing the edge flow by spreading out the existing lines to form an even grid. That's done by shifting the lines one at a time. It's a tedious procedure, but well worth the effort. By doing that, it gives me a clean palette to start cutting in new detail on this side of the model. Now, last option, for whatever reason, let's say I really needed the underside to be nearly clear of lines. What I would do is return to the detail on the other side and see how I can redirect and minimize the lines originating from that side. One of the most practical and widely used methods is to terminate lines, redirecting into one line. Usually it's to the outer edge of the corner or within the seam or control loop. That is doable on flat surfaces. However, sometimes you need to box in detail so that you don't disturb a curve or bending surface. I'll explain why later when I discuss the issue of pinching. Overall, this still needs a lot of cleanup. Here's another method. You can box in detail this way. That's all quads on this side, but I don't recommend doing this because there are too many polygons concentrated in this area. Moreover, creating geometry to divert geometry isn't a good idea. Here I have a single box around the detail and it's cleaned up a bit. That works in some cases, but here it's no good because it's still too condensed. And when subdivided, it creates a strange web effect. So, after all that, there are still more lines to manage, but there are less than before. And that smooths without any issues. However, the topology isn't terrific. In this case, the additional box isn't necessary, so I would remove it. I prefer separating detail as an entirely different shape or waiting to see if I can redirect lines at the point where new detail is needed. In my experience, having most control loops go all the way around up to the point where they need to be terminated is the best way to go. That gives me the best topology. And that's how I would do it if I were going to sell a model. Also, anything not in view of rendering doesn't get modeled. If this piece fits into a larger part, then you could leave the underside empty and then hide and divert any lines out of view. Or, if I still need a bottom, I could fit it with a separate piece to fill that space, like a real-world product. So that's an introduction to eliminating detail by redirecting lines. Now let's look at this from a different perspective. Here I have one column of quad polygons tapering off at the bottom. And when subdivided, it becomes two columns, and that triangle becomes a quad. That is two edge flows now. There are times when you need two pathways to abruptly flow into a point, like this. There appears to be a triangle here, but actually it's a quad. 1, 2, 3, 4 sides. And when subdivided, it looks like this. That made two edge flow pathways flowing into one polygon, but I still have two paths. And when I continue to model around it, I haven't really reduced the number of pathways. There's no reason to do that unless I need to make a pointy corner here. And as a side note, when you need a triangle to make a shape like this, it is best to enclose it with surrounding quads, like this. Another way you will see this is when going from 4 paths to 2, like this, with a T-vert in the center that connects with the pole. That is used to terminate small creases or seams around different areas of a model, and this is what it looks like when subdivided. Now, let's say I have a situation where I need two pathways to flow into one. If I rotate the triangle so that it's now diverting the lines outward, I've reduced the pathways going from 2 to 1. And if I continue to model around it, there are even quads on both sides. And this is what it looks like when subdivided. This has a good edge flow. Here I have two flowing into one, but it's done with a T-vert and a triangle. And this is what that looks like when subdivided. That creates irregular geometry, which may or may not be useful depending on the context of its use. What's good about this is that I can make a single path of quad polygons on adjacent sides. If I didn't like this single triangle here, I could just add a single point, and now that triangle is a quad. However, now I have two paths here and one on the other side. If the two sides eventually meet, going around the model, I'm going to have a problem. Here on this side, it's needlessly complicated. I haven't really done myself any favors by making that triangle a quad. Another way to go from 2 to 1 edge flows is by redirecting one side, like this. I prefer this method, but the side with more details still needs an avenue to redirect to. Back from where it came from is best. Now, let's say I need to reduce the complexity going from 3 paths into 1. This is the way you do that. Here, all quad shapes naturally flow into one path. And this is what that looks like when subdivided. That is the best way to reduce complexity from one side to the next. It's better to flow 3 paths into 1 than it is 2 to 1, but it's not always possible. Now I want to show you an example of how this is typically used. The fingers flows to the palm, which is less complex, and the palm flows into the arm, which is less complex than the palm. The fingers gradually reduce in complexity, going from 3 paths into 1, at the same time creating a natural set of knuckle shapes at the top of the hand. In between the fingers, 2 pathways are flowing into a T-vert, then into a pole. It makes a nice narrow crease there and reduces the complexity going from 4 pathways into 2. So, by using a combination of the same methods shown, I can converge the edge flow by any way I need. Some examples. This shape is going from 4 to 2 pathways, and that 2 can be used to terminate seams in a model. This shape is going from 5 to 2. This is going from 5 to 3. Also, you can go 5 to 3 this way. This is 6 to 2. This is 7 to 3. 7 to 4. I think you get the point. Okay, so now that you understand the concept, I'll show you how to do this. Oftentimes, you'll need to combine 2 separate objects, one with more complexity than the other. Here I have 2 separate shapes. I'll need to join them going from 4 to 2 pathways. So here I select 2 lines and one here, and press Shift B to bridge. And I would do the same for here. They are merged, but now we have to deal with the endgons. So let's divert them to the center of this polygon using the knife tool, pressing X. Holding Shift to snap to the center of this edge, and press Return to accept. So a funny thing happened here. Hexagon corrected the endgon to make another endgon. That is normal. I'll ignore it for now and make a cut on the next side. Since I don't have the geometry surrounding the shape, I can't use the Fill tool to fill this notch. Let's use the Append tool to make a free-form facet. With the shape selected, press P, and holding Shift to snap, I draw from point to point. Then press Return to apply, then return again to accept. Okay, that facet I drew is now part of the whole. Let's remove that line by dissolving it, selecting it, and pressing Delete. That's the backspace key if you're on a PC, and select Stray Only. The difference between Stray, All, and None options is a bit complicated. Stray won't dissolve poles, and that's what we want. When reducing flow lines, the All option is best, so it doesn't leave behind vertices, but you need to watch that it doesn't reach a pole. I'll need to demonstrate that another time. Alright, I'll finish this by using the Free Cut tool. Sometimes I call it the knife tool. Press X and make lines here and here. And now I just shape this using the scale handles. Another example, I connect these 4 lines, pressing Shift X, then connect these lines, pressing Shift X, then scale to shape. Sometimes you make a bevel cut to create a seam or groove, and you're left with something like this. I can divide the endgon here and ring and split it, connect these 2 vertices, and then divide the 5-sided polygons, and shape it up to make a nice rounded end cap. The triangles are tucked into the seam, surrounded by quads, so it's no problem. Sometimes I need to form a point, like a cone, gradually, and that can be done this way, using the Free Cut tool, pressing X. This is the same example in 3D form. A lot of aircraft models will have this kind of shape. Some modelers unnecessarily use T-verts in their models to fix geometry. In this example, I have several T-verts intertwining with each other in an attempt to reduce the complexity, going from 5 pathways to 1. And when subdivided, that creates a random winding mess. It's hard to say that you should never do this, because under a different context, the very same geometry is found in organic shapes. On organic models, it's okay to reduce the complexity with T-verts if it doesn't affect the shading. Sometimes I'll work on an organic model and I need to remove a series of endgons around bad topology. For example, with this shape, when I select non-4-point faces, there I can see a few triangles and endgons. We definitely need to get rid of the endgons, and maybe even normalize the overall geometry in the process. So I could continue to add lines to remove the triangles, but they are doing their job of reducing the complexity from one side to the next. Converting all triangles and n-gons into quads is sort of an art form. Converting n-gons is required, but leaving triangles is completely fine and up to you. Typically though, you don't want them in weird random places. Just watch out for good edge flow. This is important and something to keep in mind. There's no way to remove a triangle without adding or removing an entire flow line. It's just not mathematically possible. Like here in this example, I'm adding a complete flow line to remove that one triangle. In this example, I have a few triangles that when subdivided don't give me the topology I'm looking for. I used to try and reconfigure the geometry to force it to use quads like this, but that generated even worse results, and I still didn't get rid of the triangles. You simply can't merge it into the mesh without creating another triangle or n-gon somewhere else in the mesh. New modelers don't realize this, so they keep removing single edges or vertices, creating n-gons and sometimes making spiral loops all the way around a model as they chase the problem. In situations like this, stop and think about the type of edge flow you want. The only way to remove triangles is to add a flow line or remove them. In this case, it's better to eliminate the lines and then redirect new or existing ones around the shape. One thing here that's important to note, here I have an enveloped polygon. That's more dangerous than an n-gon because you can only detect it by eye. And by that time you might be well down the texturing pipeline with little options to fix it. See, this type of polygon that's folding in on itself will create a black spot or a transparent spot in your render, so it's imperative that you fix it. You have a choice: move it so that it's no longer folding inward, or remove it. I'm going to have to remove it, so I'm glad I caught this sooner than later. Now when I subdivide this, we have a nice clean mesh. Sometimes I see modelers try to shortcut the need for creating control loops by using bevels and chamfering, and they subdivide that. You can certainly subdivide a beveled shape with marginal success, but it's not going to give you great results in the long run. The issue lies with editability, topology, and shading. First, the bevel needs to be baked into the shape. You can't edit it afterwards. With most forms, you'll need to correct the topology afterwards. And then at subdivision 0, you have all sorts of shading issues. For instance, when I subdivide these simple cubes with beveled edges, it gives me this ugly glow and shadow shading effect. And that will show in my renders depending on the shading angle setting. Because there are no control loops, it takes the bevel and stretches and compresses it. The shader tries its best to blend the light between the surfaces. Trying to shortcut control loops with bevels doesn't work. However, you can use bevels in conjunction with control loops with significant effect. For example, here I have this shape with control loops holding a depression on the surface. It subdivides great. But this model at base level, the details are so sharp the edges disappear. If you have a complex model, chances are it needs to look presentable at base level. The light needs to catch all the edges. That means this model needs to have some necessary soft edges to start with. So you could provide a base mesh at sub-D level 0 and include bevel edges. That gives the end user the option of subdividing the entire model or just part of it. Once the control loops are in place, I can apply a bevel between them, like this. And I can leave this dynamic or flatten it and alter the bevel to give it some extra punch. Now I can hit this outer edge with a bevel. I'm using the chamfering tool. That's Command-Shift-Option-C. With that, I can change the radius and the range, but unfortunately I can't change the profile. I need to alter that afterward manually. On outer edges, I'll use the range of 0 and press Accept, and then have a look. For corners like these, you never want to go above the range of 2. I stick with 0 and 1. If I didn't like how that was looking, it's dynamic right now, so I can press this button and change the radius and range. And that's looking better. That looks pretty good as a base mesh, but when subdivided, it's even better. If this were rendering from a distance, I wouldn't even need to subdivide it. And that's the benefit of using this method. I have that option. Here's another example. First, what I would do is block out the shape. Then give it more definition and correct edge flow. Then apply my control loops and test the subdivision. That looks good. Before I bevel, it's essential to remove the subd from the dynamic panel. Then I carefully select all these outer edges. And apply a chamfer, Command-Shift-Option-C. And for this, I wanted to make sure the range is 0. And then adjust the radius so that it's an even distance from the control loops. From a distance, this looks pretty good. I think the control loops could have been tighter, but you get the idea. The thing is that I could still alter both the control loops and the bevel as much as I want. And when I subdivide this, in the DG panel, I see this, it stacks. I can select this here and alter the bevel. And also still increase and decrease the subd level. And I can still alter the control loops. It's a little tricky, but it's doable. Briefly now, I wanted to touch on this issue of pinching because it'll come up from time to time in other tutorials. And that's the best time to show you how to fix it during the real modeling situations. But what is pinching? Pinching occurs on curved surfaces. And it's when you see these small bumps on the surfaces, often referred to as deformations. It happens when you have uneven geometry or poles on a curved surface. In this case, the pole causes the pinching, and I could try to normalize the surface to eliminate the pinching effect, or avoid using poles altogether. Here I have a flat surface, with a set of lines converging into one using triangles, a T-vert, a pole, a dense collection of lines with triangles and uneven spaced lines. And when subdivided, there's no issue, no pinching. But when looking at the same geometry along a curved surface, there are all these unwanted bumps. It's sometimes hard to spot until you look at it from an angle. This is unwanted deformation caused by poles, triangles, and uneven topology. There are several ways to fix this. First, the triangles would need to be converted into quads by adding more flow lines, or redivert the triangles to a point where there is a flat surface. The pole would have to be removed by converting the triangle into quads. As for the uneven geometry, well, it's hard to say how to fix this, because did I mean to have it slope like this and hold the corner? I would have to see it in a real modeling context. But typically I would have to remove the lines or spread the lines apart to create an even flow. And here's an example of all of those edits applied. You won't always be able to fix pinching entirely, but you can remedy the problems to the point where it's acceptable. The running joke is that the best way to remove pinching is to apply heavy texture. One way you'll see deformation on a flat surface is with non-planar faces. If I right-click and choose Advanced Selections and choose Non-Planar Surfaces, that will select all the non-planar faces. This is a set of non-planar polygons that shouldn't be here, and that is what is causing the subtle distortions around it. And if I subdivide this, it doesn't solve the problem. To fix this, I could pinpoint the offending points and, using the position properties, fix each point. This could take a while. So what I like to do is select all the surfaces, flatten, and reposition. And just so you know, whenever you bend a polygon like this, you're making it non-planar. This distortion forces the shader to make its best guess. It needs more geometry to shade correctly. Subdividing it also corrects it. Non-planar faces are fine on curved surfaces, but on flat surfaces it could cause unwanted deformations. That's just something to be aware of. Of course, if your intent is to create a bumpy surface, have at it. Use all the non-planar shapes you want. So that's all I have for today. In the next tutorial, we'll take everything we learned from this and the other videos and build a complete model. See you again soon. Take care.